Imagine your brain is trying to learn a new skill, like hitting a tennis ball. Every time you swing, you're making a choice. In the world of artificial intelligence, we call this a policy. But for a long time, teaching an AI to improve that policy was like walking a tightrope over a canyon. One step too far, and the whole system would collapse. The story begins with a problem called the policy collapse. In traditional machine learning, we use gradients to tell the AI which direction to move to get better. But here's the catch. A small change in the math, the parameters, can lead to a massive, catastrophic change in behavior. 1 second the AI is learning to walk, and the next, it's twitching on the floor because the step it took was just a fraction too large. To fix this, we have to look at the baseline. Think of this as a reality check. Instead of the AI just looking at how much reward it got, the baseline asks, how much better was this action compared to what I usually do? By focusing on this relative advantage, we filter out the noise and start to see the true path to improvement. But even with the baseline, we still face the data hunger problem. Normally, an AI takes one tiny step and then has to go back and collect thousands of hours of new experience just to figure out the next step. It's incredibly slow. This is where the magic of the clipped objective comes in. This is the heart of PPO, or Proximal Policy Optimization. Instead of letting the AI change as much as it wants, we wrap the learning process in a safety net. We tell the AI, you can change, but only by a tiny percentage, maybe 20% at most. If the update tries to push the AI further than that, we clip it. We stop it from overreacting to a single lucky break or a single mistake. This forces the AI to stay within a trust region, ensuring that every new version of the policy is just a slightly better, more stable version of the last one. By combining this clipping trick with the Actor-Critic framework, where one part of the AI acts and another part critiques, we get a system that can take multiple steps of learning from the exact same experience. It's faster, it's safer, and it's the reason why modern AI can master everything, from complex video games to human conversation. We've moved from a world of unpredictable collapses to a world of steady, monotonic improvement. We are no longer just guessing which way to go. We are systematically climbing the mountain of intelligence, one safe step at a time.